My beautiful people, right, welcome back, grade 10. So today we're going to be doing powers of prime bases. Okay, so now we're going to get into some interesting things. Okay, it's going to become beautiful now. All right, let's just dive straight into it. Okay, so if I talk about powers, what do you think of immediately? What do you think of? You think of exponents. Good. Okay, and if I talk about prime, good. We're talking about prime numbers. Okay, so like 2, 3, 5, 7. 11, 13, and so on and so forth, okay? And if I'm talking about bases, and if we're working with exponents, bases we're talking about, okay, the base number. Okay, remember, for exponents, okay, we have a base number, okay? So we've got a base number, so let's say 2, all right? And then we've got an exponent, so I don't know what it is, call it x, all right? And this base, okay, has to be a prime number, okay? We're working with a base. All right, and we're going to be working with powers as well. Okay, so that's basically all this means, okay? And it's going to help you understanding what this means, okay? It's going to help you solve these questions, okay? So let's look at some examples of what I mean by this. Okay, so what is this? Okay, what do I see here? Okay, so first thing, I need prime bases, all right? Because what are we doing? We're busy doing powers of prime bases. Okay, so I need to look at everything that I have, okay? And I need to look at all my bases. Okay, so I've got 25, 5, and 5, and I need to ask myself a question. I need to say, okay, look at these bases, right? Do I have prime numbers for all of these bases? Okay, so is 5 a prime number? Yes. Is 5 a prime number? Yes. Is 25 a prime number? No, 25 is not a prime number, but how am I going to change it into a prime number? Because I can. There's a way. All right, how am I going to change 25 into a prime number? Okay, so if you go to your calculator, if you have a scientific calculator, okay, so a Casio calculator, all right, you type in 25, okay, say equals, all right, go to shift, press shift, and then look for the fact button, okay, the fact button, and press that. And what does your calculator give you? Okay, it gives you 5 squared. Okay, it gives you 5 squared, right? And I'm going to put this in a bracket. Okay, every time I change something, I always put it in a bracket just to be safe. All right, and so if I put this 25, okay, I've changed 25 to 5 squared, right? And what is outside of the bracket there? X. So I'm going to keep the x outside of that bracket there. All right, moving on. All right, I know that 5 is a prime number, so I'm going to keep him exactly the same. Okay, so 5 stays. Okay, and we've got 2x plus 1 over there. Okay, all divided by, okay, same 5. Right, and that's all going to stay the same. Nothing's going to change there. Okay, that's 3x plus 2. Alright, so now let's simplify this bracket. Okay, I don't want that bracket there anymore. Okay, so how am I going to simplify that? Okay, I see I've got an exponent outside of a bracket, so what am I going to do with the exponents inside? Okay, I'm going to multiply. Okay, I'm going to multiply whatever's outside with whatever the exponent is inside. Okay, so I'm going to have 5. Okay, and what is x times 2? It's 2x. Very good. All right, multiplied by, okay, 5, whatever that is, 5 squared, 5 to the power of 2x plus 1. Okay, that all stays the same, nothing changed. All over 5 to the 3x plus 2. All right, now I'm left with this big guy over here. Right, I still don't know what am I going to do here. Right, but now remember in my previous video, okay, we learned about exponents. Okay, we learned about same bases and what happens when we multiply, what happens when we divide same bases. All right, so here we've got same bases. Okay, you can all see that we've got 5s there. Okay, we've got same bases of 5 everywhere. Okay, there's a 5 there. All right, there's a 5 there. Okay, and there's a 5 there. Okay, can we all see the same bases there? All right, now at the top, if you look at just the top, okay, we've got 5s, and what's happening with this 5? What does that dot mean? Okay, the dot just means multiply. Okay, and now here at the top, I see that I've got same bases being multiplied. Okay, so what do I do with the exponents? We're just going to add them. Okay, But also, I've got a same base that's being divided. I'm dividing by a same base of 5. And what do I do when I divide same bases again? I minus. Alright, so what we're going to do first, okay, we're going to keep the base of 5. Okay, we're going to keep it. Alright, and then we said we're going to do something. We're going to do something with these top ones. What are we going to do with these top 5s? We're going to add the exponents. So let's add them here. All in one line. We're going to say 2x, okay, plus 2x plus 1. And then we said, okay, we're also dividing by a 5. Okay, we're also dividing by a same base. So what are we going to do with these exponents here? What are we going to do with those? Okay, we're going to minus it. Okay, so we're just going to minus them. All right, and what happens now that I have two terms? When I have two terms, I always put brackets, all right, because I'm minusing the 3x and I'm minusing the 2. Okay, so I've got 3x plus 2 in a bracket, right? And now let's simplify this. Okay, so if I simplify this, okay, we're going to have 2x plus 2x plus 1, okay, minus 3x and minus 2. Right, I can still simplify that exponent. Okay, why? Because I've got common like terms there. Not common, what am I talking about? Okay, I've got like terms. Alright, I've got my x's and I've got my numbers. Alright, so let's equals here. Right, and we're going to say 5. Okay, and what is 2x plus 2x minus 3x? Okay, it's just x. Good. Alright, and what is 1 minus 2? It's negative 1. Alright, and that's your answer. Okay, so let's just go through some of these things again. Alright, so over here, the first thing we do, we want all of our bases to look like what? Prime numbers. Okay, prime bases. We want to get prime bases, alright? So we got our prime base. Okay, we kept everything in a bracket, remember? And then we said, okay, we're going to keep the x outside, okay, and everything else stays the same. Alright, then we see that we've got an x outside of a bracket, okay, and it's an exponent. Okay, so when we see that, we multiply that exponent that's outside of the bracket with all the exponents that are inside the bracket. Okay, so we said 2 times x is 2x, right? And then everything else stayed exactly the same. Nothing changed. Okay, so 5 to the 2x plus 1 and 5 to the 3x plus 2 goes to the bottom of that fraction. Okay, then we said, okay, we watched the previous video and we know that when we see same bases, busy multiplying here, we know that we're going to add. Okay, so we added 2x plus 1. Here it is, 2x plus 1. All right, but we also see that we're dividing by a same base. Okay, so what happens when we divide by same bases? We minus. Okay, so we're going to minus whatever this exponent is, and it's the whole exponent that we're minusing. Okay, so we're going to take it and we're going to put it in a bracket because we've got more than one term. Okay, put it in a bracket, nice. Multiply that negative in, and we've got negative 3x minus 2 here, and everything else here stays the same. And then we added our like terms, and we got there. Alright, hoping that makes sense. Alright, so let's go on to the next example. Alright, so now we look at that. I want you to pause the video, see if you can tackle that on your own. Alright, and then play the video once you've done it. Alright, so let's look here. Okay, so first thing I always need to look for, I need to first look at my bases. Okay, so I've got 5s, I've got 3s, I've got 5. Whoop, I've got a 25. Whoop, I've got a 9. Alright, what do I need all my bases to be? I need them to be prime numbers. Alright, prime bases. I need my prime bases. Alright, so how am I going to change 25 into a prime base? Okay, we can change it to 5 squared. Okay, remembering from the previous example. Okay, so we've got 5 squared. Okay, or if you didn't remember from the previous example, you can put 25 into your calculator, say equals, press shift and fact, and you pop out whatever your calculator gives you. Whatever your calculator gives you, you put that in a bracket. Alright, okay, and what was 25 raised to the power of? X. Alright, so we've got 5 squared in a bracket raised to the power of x there. Okay, so I'm going to have to do something to that later. Okay, multiplied by 5, which is already a prime base. Nothing's going to change here. 5 to the power of 2x plus 1. Very awesome. All right. Whoop. Okay, I've got a 9 here. All right. That's not a prime number. 9 is not a prime number, but I can change it into a prime number. How am I going to change 9 into a prime number or prime base? All right. We put 9 into our calculator. We say equals, and we say shift, and we say fact, and we see that 9 is equal to 3 squared. Okay, so whatever my calculator gives me, I put it in a bracket. Okay, please remember that bracket. Okay, and here we've got x minus 1, okay, as our exponent. All right, and that is all over whatever's at the bottom. Okay, so my 5 is already a prime base, and my 3 is already a prime base, and nothing's going to change there. Okay, so I've got 5, 3x plus 2 multiplied by 3 to the power of 2x plus 2. Fantastic. All right. Now let's simplify at the top a little bit. All right. So we've got x multiplied by 2, and we get 5 to the power of 2x. Awesome things. All right. Then we've got 5 to the power of 2x plus 1. Awesome stuff. Multiplied by. Okay, so now careful here. Okay, careful here. A lot of people, a lot of students make a lot of mistakes here. All right, so we see that we've got this exponent, the whole exponent, which is x minus 1, okay, as a whole, multiplying with 2. Okay, so basically what you have here is you've got that whole exponent, x minus 1, multiplying by 2. All right, so can you see the brackets? All right, so a lot of students will just say, okay, no, I'm just going to say 2 times x, which is 2x, and then I'm going to keep the minus 1. Okay, this is wrong, guys. Okay, it is wrong. Why? Because 2 times x is 2x, and 2 times negative 1 is negative 2. All right, so please, when you have a case where you've got exponents that have 2 terms, all right, please multiply this 2 with both of these terms, okay? So to be safe, okay, I would like you guys to please do this. Okay, so now you can always, there's no mistakes here. Okay, so 2, and you put your exponent in a bracket. 2, and your exponent in a bracket. Okay, so now my 2 is going to multiply in here later. All right, and that's all over my denominator here, which is to the power of 3x plus 2, and 3 to the power of 2x plus 2. All right, let's simplify this 3 now. All right, so we've got 5 to the power of 2x multiplied by 5 to the power of 2x plus 1. All right, and then over here we've got 3 to the power of 2 times x, which is 2x, and 2 times negative 1, which is negative 2. All right, and that's all over my denominator, which still hasn't changed yet. Okay, which is 3x plus 2, and 3 to the power of 2x plus 2. All right, so I'm not finished yet. Okay, but I've simplified, and I've got all my prime bases, and I've got all my exponents there. All right, so now what am I going to do now? Okay, now I look at all my common prime bases, all the ones that look the same. Okay, and I'm going to deal with each of them separately. Okay, so let's look at the 5s. Okay, all the 5s. Okay, so I've got 2 5s at the top and 1 5 at the bottom. All right, so going here now. Okay, so I'm running out of space. Okay, so I'm going to do with just my 5s. Deal with just my 5s now. Okay, so at the top, I see that I've got 2 5s being multiplied with each other. Okay, there's a 5s multiplied with each other. What do I do with same bases that are multiplying by each other? What do I do with exponents? I add those exponents. Okay, so let's add them in one line here. So we've got 2x, okay, plus 2x plus 1. Fantastic. All right, but I also see something here at the bottom of this fraction. I see that there's a 5 at the bottom. Okay, this 5 is dividing. Okay, so what do I do with same bases that divide? I minus those exponents. Okay, so I'm minusing. Am I just minusing the negative 3? The negative 3x? No, I'm minusing that whole thing. Okay, so I'm going to put that whole thing in a bracket. Okay, which is 3x and plus 2. Alright, do you guys see that? Awesome. Okay, multiplied by. Okay, now I'm going to deal with all my 3's. Okay, because my 3 is not the same as 5. Okay, so let's look at all my 3's. I've got a 3 here at the top, and I've got a 3 here at the bottom. What do I do with same bases that are dividing? I minus my exponents. Okay, so let's look here. So we've got 2x minus 2. Okay, and we're minusing what? This whole exponent. Okay, this as a whole. So what must I do with this exponent? I must put it in a bracket. Awesome things. Okay, so I've got 2x and plus 2. Alright, and I keep it in a bracket. Alright, now I can simplify things here. Okay, I can simplify my exponents. Okay, so I've got base of 5, and I've got 2x plus 1 minus 3x minus 2. Right, multiplied by 3 to the power of 2x minus 2 minus 2x minus 2. Right, do you guys see that? Awesome stuff. Are you guys getting excited? We're getting close to the answer now. Alright, let's check. Okay, can I simplify my exponent here? Yes, I can. I can add those like terms together. Okay, so what is 2x plus 2x minus 3x? Okay, we've got just x. Right, and what is 1 minus 2? It's minus 1. Alright, okay, and that exponent is as a whole, okay, of x minus 1. Right, multiplied by, okay, 3, and we've got 2x minus 2x. Awesome, that gives me 0. Okay, so those cancel out, the x terms cancel out. Okay, and then I've got minus 2 minus 2. This gives me minus 4. Awesome stuff. Alright, so now if I tell you that I want positive exponents, right? I want this answer in positive exponents. Okay, what are you going to do? Okay, so let's first determine my negative exponents. Okay, so here I've got 5, and yes, okay, I've got a negative 1 inside here. Okay, but this is as a whole. Okay, so is there a negative in front of this bracket? No, so I'm going to leave this as it is. Okay, so I'm going to leave it. Alright, but what am I going to do with this one? This one, if I put a bracket around this exponent. Alright, there's a negative here. It's just negative 4. Okay, so it's just negative 4. There's nothing else. There's no x in the front there. There's nothing else. Okay, so I'm gonna take this and I'm gonna take it to the bottom. Alright, so I'm gonna keep my 5 x minus 1 there. Okay, and underneath I'm going to write my 3 to the power of positive 4 now. Alright, and over here, okay, we can simplify 3 to the power of 4, and 5 x to the minus 1 stays, and 3 to the power of 4 is 81. Alright, cool. I hope this is making sense to you guys. Right, I hope that makes sense. If there's anything in this example that you didn't understand, maybe just rewind the video, watch it again. Alright, and let's go straight to the last example for today. Okay, so I want you to pause the video, see if you can do this by yourself, and then you can play the video with me. Okay, so if I look at these bases here, I've got 2, I've got 4, I've got 9, I've got 16, I've got 18. Alright, but I need prime bases. Alright, I need all of them to be prime numbers. Okay, so if I look at my bases, there's 2, there's 4, there's 9, 16, and 18. Alright, so if I look at that, alright, which ones do I have to change? Is 2 a prime number? Yes, it is. Okay, so that's going to stay the same. Okay, is 4 a prime number? No, but I can change it into one. Okay, so I put 4 into my calculator, I say equals, I say shift fact, and I've got 2 to the power of 2 in my calculator, and that stays in a bracket. And what goes outside the bracket? To the power of 2x plus 1. Fantastic. All right, multiplied by. Okay, we've got 9 here. All right, so I can change that to a 3 squared, remembering from our previous example. Put that in a bracket, and I've got x minus 1 outside there. Okay, and that is all over. All right, if I put 16 into my calculator, okay, and I say equals and I say shift, in fact, what do you get? You get 2 to the power of 4. Okay, all in a bracket. Outside that bracket, it's an x. Right? And then I've got multiplied by. If I put 18 into my calculator and I say equals and I say shift, in fact, what do you get? Okay, now you've got two numbers. Your calculator spits out two numbers. This is what your calculator says. It says 2 multiplied by 3 squared. Okay, and remember, what did I say? Whatever your calculator gives you, you put it in a bracket. Okay, because this over here is 18. Okay, so you put everything in a bracket. Okay, and what goes outside the bracket? X. Right, so whatever your calculator gives you guys, put it in a bracket. Okay, put that whole thing in a bracket and I'll show you why. Okay, so moving on. Alright, we're going to say equals. Let's simplify now. Okay, so 2x stays the same. Okay, multiplied by. Alright, so now this 2, is it just multiplying with the 2x? No, it's multiplying with the 1 as well. Alright, so we're going to say 2, okay, to the power of 2 in a bracket, 2x plus 1. Alright, multiplied by 3, and that 2 is multiplying with this whole thing again. Okay, so I've got 2 bracket x minus 1. Right, and that's all over. Okay, here I've got 4 times x, which is 4x. Yeah, I've got now over here. Alright, so when I had examples like this in my previous video, I had a, b, okay, I had a bracket, and I had to the power of 2, for example. Okay, what did I do with that 2 now? Okay, I multiplied with both of these exponents here. Okay, so a is raised to the power of 1, b is raised to the power of 1 as well. Okay, so you're going to say 2 times 1, which gave you a squared, and you said 2 times 1, which gave you b squared. Okay, so a and b is being multiplied together, and so is 2 and 3. Right, so what's the power of 2 here? Okay, 2 is being raised to the power of 1. Alright, so this x is going to multiply with both of these exponents that are inside here. Alright, so I've got 2 and 1 times x. It's just x. Okay, and multiplied by 3. Okay, and what is 2 times x? 2x. Okay, so I hope you guys see that. Okay, please take note of this. Alright, so this x is being multiplied with both of these numbers exponents that are inside here. Right. Now I'm going to simplify a little bit further. Okay, so I've got 2 to the power of x multiplied by 2 to the power of 2 times 2x, which is 4x, and 2 times 1, which is 2, right, multiplied by 3 to the power of 2 times x, which is 2x, and 2 times negative 1, which is negative 2, all over. Okay, 2 to the power of 4x, okay, multiplied by 2 to the power of x, multiplied by 3 to the power of 2x. Alright. Okay, so over here, now what we're going to do is we're going to group all of our same bases. Okay, so let's look here. Okay, I've got 2's and 3's. So I'm going to just deal with my 2's first. Okay, so let me highlight my 2's. So can you see here? I've got 2 2's at the top. Alright, and then they're same bases. What do I do with same bases that are being multiplied together? You add them. Okay, so I'm just going to go to the top here. I'm running out of space. Alright, so I've got 2. Right, and I'm going to add those exponents now. So I've got x plus 4x plus 2. Alright, but I also see something at the bottom there. Okay, I see that I've got a 2 and a 2 at the bottom. Alright, so what am I going to do with each of these exponents? I'm going to minus both of them. Okay, so I'm going to minus the 4x Okay, and I'm going to minus the x. Okay, so I don't have to put brackets around the 4x, okay, because it's just one term. And I don't have to put brackets around that x because it's just one term. Okay, but I'm going to minus both of them. So minus 4x and minus that x there. Okay, and that's being multiplied by 3. Okay, 3 is my other prime base that I've got there. Alright, so I've got 1 3 at the top, and I've got another 3 there at the bottom. Alright, so what do I do with same bases that are being divided? Okay, I minus the exponent. So here at the top, I've got 2x, whatever the top one is. So I've got 2x minus 2. Minus, what's the bottom? It's just one term, so I can just minus 2x there. I don't have to put a bracket around it. Right, now I can simplify my exponents a little bit there. Alright, so I've got 2 to the power of x plus 4x, which is 5x, minus 4x, which is 1x, minus x, which is 0. Fantastic, all my x terms cancel out. Okay, and then I'm left with a positive 2 there. Okay, multiplied by 3. Okay, let's add these. Okay, so I've got 2x minus 2x. Okay, it's 0. Fantastic. Those cancel out. Right, and I'm left with a negative 2. Alright, but if I say, okay, if my question said I want positive exponents, what are you going to do? Okay, I look at all my negative exponents. Okay, so I see that this prime base has a negative exponent. Okay, that's the only one that has a negative exponent. Okay, so what am I going to do with this to make it positive? To make it a positive exponent? I'm going to take it to the bottom. So I'm going to open up a division line and I'm going to take it to the bottom and it becomes positive. Okay, so now where is this 2 to the power of 2 going to go? Is he also going to come to the bottom or is he going to stay at the top? He's going to stay at the top where he is. Alright, because there's no negative exponent there. Okay, so he doesn't move, he stays there. Alright, but I can also still simplify those. Okay, so what is 2 to the power of 2? 4. And what is 3 to the power of 2? 9. Right. Isn't this just amazing? Isn't it exciting? Okay, grade 10 maths is starting to get exciting now. Alright, so I hope that you guys are understanding powers of prime bases. Alright, and yeah, if there's still things that you don't understand, maybe message in the comments and maybe I'll start making a video on some of the questions that you guys still might have about these. Yeah, I just hope that this was helpful and that it helps with your tests and exams. Okay, good luck, grade 10s.